Welcome to Learning with UNP. In this session of Python for Data Science, we are going to understand about Tuple Basics Part 1. That includes Introduction to Tuples, creating a tuple, understanding about length function in tuple, characteristics of tuples, and finally Tuple Constructor. Let's begin with understanding about tuple. Tuples in Python are immutable sequences used to store collections of items. They are similar to lists, but their immutability means their elements cannot be changed after creation. Tuples are often used to group related data together. A tuple is a collection of ordered and immutable elements. Tuples are defined by enclosing the elements in parentheses and separating them with commas. They are often used to store related pieces of information together, means it is used to store multiple items in a single variable. Let's now look at creating a tuple. Tuples can be created by placing comma-separated values inside parentheses. An empty tuple is created using empty parentheses and a single element tuple requires a comma after the element. Here is a syntax to do so. Tuples can hold items where empty tuple has none, single element tuple has one item with a comma, and multiple elements tuple has several items separated by commas. Let's look at the pseudocode representation of it. Step 1. Create an empty tuple with parentheses. Means to make an empty tuple, use parentheses with nothing inside. Step 2. Create a single element tuple with element and comma. Means for a single element tuple, add the item followed by a comma inside parentheses. Step 3. Create a multiple element tuple with element 1, element 2, element 3, so on. Means to create a tuple with multiple items, list them inside parentheses separated by commas. Here is an example to illustrate how to create different types of tuples in Python. An empty tuple is created using parentheses. A single element tuple is made by placing the element followed by a comma inside parentheses. And a multiple elements tuple is formed by listing the elements separated by commas within parentheses as 1, 2, 3. Here we use the print statement to print all these tuples. Let's execute this and check. As discussed, here is the output. Next comes understanding length function of a tuple. Length function is used to find out how many elements are there in a tuple. Here is the syntax of it. This line will store the number of elements in my tuple into the variable length. Let's look at the pseudocode representation of it. Step 1. Create a tuple means start by defining a tuple with some elements. Step 2. Call the length function with the tuple means use the length function and pass the tuple to it. Step 3. The function returns the number of elements in the tuple means the length function will return the total count of elements in the tuple. Step 4. Assign the result to a variable length means assign this count to a variable such as length. In this example, we create a tuple named myTuple that contains 5 different elements, an integer, a string, a float, a boolean, and another tuple. We then use the length function to determine the number of elements in myTuple and store the result in the variable length. Finally, we printed the value of length, which will output 5 because there are 5 items in the tuple. Let's execute this and check. As discussed, here is the output. Now, let's look at the characteristics of a tuple. First comes ordered. Tuples maintain the order of elements. This means that the order in which elements are added to the tuple is preserved. Second comes immutable. Tuples are immutable, meaning their elements cannot be changed, added, or removed after creation. Their elements remain fixed. You can't modify them. Third comes LF duplicates. Tuples can contain duplicate elements. This means that within a tuple, you can have the same value repeated multiple times without any problem. A tuple can contain multiple occurrences of the same number, string, or any other type of data. Here are examples demonstrating characteristics of tuple. This example illustrates the characteristic of tuple being ordered. In this example, my tuple is created with the elements 1, 2, and 3 in this order. When we print my tuple, the output will be 1, 2, and 3 following the same order. The second example demonstrates the immutability of tuples. In this example, my tuple is created with 1, 2, and 3 as elements. However, when we attempt to change the value of the second element from 2 to 4 using my tuple of 1 equals to 4, Python raises an error. The error arises because tuples are immutable in Python. indicating that their elements cannot be altered once they are defined. Attempting to modify a tuple by assigning a new value to one of its elements, such as my tuple of 1 equals to 4, leads to a type error. To allow modifications, you should use a list instead of a tuple. The same is explained here. The third example demonstrates that tuples can indeed contain duplicate elements. In this example, my tuple is defined with several elements, including integers like 1, 2, 4, etc., and floating point numbers like 2.22, 3.33, etc. Noticeably, some elements like 2 and 3.33 are repeated multiple times within the tuple. We print this using the print statement. Let's execute all these three and check. As discussed, here are the outputs of all these three examples. Now, let's move on to the last topic, that is tuple constructor. The tuple constructor in Python is a built-in tool used to create tuples, which are immutable sequences typically used to store collections of heterogeneous data. The tuple constructor can take an iterable such as list, string, or another tuple as an argument and convert it into a tuple. If no argument is provided, it creates an empty tuple. Using the tuple constructor provides a flexible way to generate tuples from different types of data or different data types. This flexibility is handy, especially when you want to maintain data integrity and prevent changes throughout your program. For example, tuple converts a list into a tuple. Similarly, tuple converts a string into a tuple of characters. This constructor is particularly useful when you need to ensure immutability of data that might be passed or transformed within a program. Additionally, tuples created using the constructor inherit the characteristics of tuples in Python. They are ordered, can contain duplicate elements. Furthermore, you can perform indexing and slicing operations on them, enabling easy access to specific elements or subsets of the tuple's data. This line of code creates a tuple named myTuple using the tuple constructor function. It takes an iterable object like a list, a string, or another tuple as input. The tuple function then converts this iterable into a tuple. Let's look at the pseudocode representation of it. Step 1. Define an iterable. Example, list string. Means start with some iterable data like a list or a string. Step 2. Call the tuple constructor with the iterable. Means call the tuple function with the iterable as its argument. Step 3. The constructor returns a tuple containing the elements of the iterable. Means the tuple function converts the iterable into a tuple, preserving its elements. Step 4. Assign the result to a variable myTuple. Means save the resulting tuple into a variable. For example, myTuple. This example here demonstrates how you can easily create a tuple from a list in Python. In this example, we start with a list named mylist containing three elements 1, 2, and 3. Then we use tuple constructor to convert this list into a tuple. Essentially, tuple of mylist takes each element of the list and put it into a new tuple, preserving their order. Finally, we print the resulting tuple myTuple using the print statement. Let's execute this and check. As discussed, here is the output. This example illustrates how to convert a list into a tuple. In this example, mylist is a list containing different types of data. We then use tuple constructor to convert this list into a tuple named myTuple. Each element of the list becomes an element of the tuple. Finally, when we print myTuple, it displays the elements of the tuple which are the same as those in the original list, but now in tuple format. Let's execute this and check. As discussed, here is the output. Finally, the last example showcases the conversion of a string into a tuple. In this example, we convert a string called myString into a tuple named myTuple using the tuple constructor. When tuple constructor is applied to the string, the constructor converts each character of the string into an individual element within the tuple. Therefore, myTuple contains each character of the original string as separate elements, maintaining their order. When printed using the print statement, myTuple displays the characters of the string as individual elements within the parentheses. Let's execute this and check. As discussed, here is the output. This is all about today's lecture. See you in the next lecture. Thank you.